Hello everyone, my name is Vidhanti Ashok Patil. I am today here to present TI component activity of an LOT subject. So let's begin. So here is a summary of an eigenvalue and eigenvector. So before starting the question, we will look towards the summary. So in these these three will be useful in that question. So first S1, the sum of all diagonal elements. S2, sum of minor of diagonal elements and the determinant. This is also called the determinant of A. So let's begin towards the question. So first, here is in given matrix, we have to find the value of eigenvalues and eigenvector. So let's begin. But we will begin with the characteristic equation. So just write the characteristic equation. Equation of matrix A. Then we will write the general equation which will be needed for us in a question for finding the eigenvalues. So after this we will find an S1 and S2 and the determinant of A. As we know, we have discussed that the all diagonal elements are it is needed to find the S1. So our S1 is 6. Now move towards the S2. So all when we multiply it and then we are doing the addition, we get the S2 value, it is an 11. Now after this we will find determinant. It will be easier because with the help of the calculator. So after taking the values, putting the values in the calculator, we get determinant. It is an 6. Now, this all three values we will put in our general equation. So, just see. Now this when we are putting this equation, we are getting the three values that are 1, 2, 3. These are the eigenvalues. So it will be written in the form of lambda 1 equals to 1, lambda 2 equals to 2, lambda 3 equals to 3. Are the eigenvalues of matrix A. After this, now we will find for an lambda 1 the eigenvectors. So this vector is corresponding to eigenvalues, that is lambda 1 equals to 1 is given by the characteristic equation A minus lambda I x equals to 0. Now all we will put the matrix, then the lambda value, then identity matrix, and then x. So just let puts. We are taken the lambda 1 value, then identity matrix 1 0 1 0 1 0 0 0 1. After that we will take an x, x1, x2, x3 that are equal to 0 0. While when we are doing the multiplication with when we are doing this total sum of that, we are getting the new matrix. It is a 0 0 minus 1 1 1 1 2 2 2. Now, in this, we will consider then two equations to find the eigenvector. Now, I am considering the two equations, that is R1 and R2, this both. So, I will write here, consider R1 and R2 from equation, for equation. So, this 0x1 plus 0x2. Here is minus, so minus plus minus get minus. It is an x3 equals to 0. This we added first equation. Now second, x1 plus x2 plus x3, we will get 0. Second equation. With the help of, there are two methods, that is a free variable and Cramer's rule. So we will take the Cramer rule because Cramer rule is easier for this and the solution is getting so fast. So I will take the Cramer rule. By Cramer's rule. So when we are taking the x1, when we are putting for the x1, we will take these two elements. So first is 0, 1, 1, 1, minus 1 is, then it is equals to x2. It will be 0. I will take for the x2, that one, this one and 4. Minus 1, 1, 1. x3, 0, 0, 1, 1. Okay. Then, after we are doing the multiplication of these three, we are getting the x1 equals to 3, x2 equals to 3, and x3 equals to 0. Now, for x1, so we will put this all three values in a vertical matrix. So t, 0. We will take t equals to 1. So it will become 1, 1, 0. We have taken this all for an x1 lambda 1. Now now for lambda 2 equals to 2. Okay. So which we have done the step by step in our first for finding lambda 1. That steps are also repeating for lambda 2 and lambda 3. So when we are finding the eigenvector of a lambda 2 means x2, that process will be same. So I will directly written the final solution of that. So for this, similarly for lambda 2, we will follow the upper steps and process for that. So I will write here the final value, final answer for an x2. This is a final answer of an x2. So first take t equals to 2. Then our x2 is simplified by minus 2. Then 1. Then 2. So this we have solved lambda 2. Now for lambda 3, we are doing the same process. Similarly, just I will finalize the answer for lambda x3. That is in 2 minus 1, 2. So we have seen the finding the eigenvalue and eigenvector by this question. So just summary the all So this is for today all. We have taken the question on an item like an item vectors. So basically, thank you.